So before we work a couple samples here, something that you may have noticed is that between the vertex form and the intercept form and standard form, there's many different ways for us to move back and forth between the two types, between the three types of quadratic forms. Now, the intercept form is what we would simply call the factored form of a quadratic. So if we took the standard form and factored it, you would end up with the intercept form, and so that's one of the reasons why factoring is an important process. The vertex form is what we call a form after we complete the square, and that's a process we're going to learn a little bit later in the unit. So if you took the standard form and completed the square with it, you would create the vertex form. Now, to go from intercept back to standard or vertex back to standard, we could simply just multiply the terms back together, and of course, if we're in the intercept form, that's the old foiling process or distributive process. So be comfortable with moving back and forth between standard form and vertex or intercept form. That's going to be an important process in this unit. So let's take a look here at these intercept form graphing problems. Here we have just a pretty straightforward problem. We have to identify our intercepts first, and so I'm going to do that. And we have a 3 that we're going to match up with a 0. We're going to have a 1 that matches up with a 0. Remember, the 3 and the 1 do not go together. They're the zeros of the function. They give us two separate points, and so that gives us 3, 0 and 1, 0. And of course, the axis of symmetry is going to be directly in the middle of that, and so that's going to be the vertical line of x equals to 2. Now, that's a very important part right there, because we need to be able to evaluate this function at f of 2. And when we do that, when we plug 2 in for x, what we're going to get is a -1. And so that's going to give me a vertex of 2, -1. So 2, -1. Now, here's a problem with this method sometimes. You can't just graph that, because even though we know it's standard, you don't have a real clear view of where that vertex is going to go. And so what I would like you to do is possibly t-chart an extra point. In this case, I'll just t-chart 0, which is going to give me 3. Now, when I do that, I go 0 and 1, 2, 3. That's also going to give me a symmetrical point on this side, and that gives me the 5 points that is necessary to get a clear picture of the intercept form. Alright, and so that's graphing a quadratic with an intercept form. We have one more example here that we're going to work on. Now you can see the a value equaling to 2. We know this is going to be a bit steeper than the normal one. Now we have opposite signs here. We have x minus 1, x plus 1, so I know that I'm going to have one of them is 1, 0, and the other one is -1, 0. And that makes our axis of symmetry pretty straightforward. Now our axis of symmetry in this case is the y-axis. Now if we ask you to write that as an equation, you must write it as x equals to 0. Very important that you understand how to write vertical lines as an equation. Now, in finding the vertex, we just need to evaluate this for f at 0. And when we do that, we get simply a value of -2. And then we can plot 0, -2. Now again, this doesn't give us a real clear picture of where we need to be. So a t-chart with another point would be good. And I could either go to a +2, I could go to a -2. It's not going to matter. And when I do that, I get 2 and then 6. And of course, I'm going to have the -2, 6 as well. And so you can see that that's a much steeper quadratic. Alright, and there are your examples of graphing an intercept form.